how to do the radical problems on the Alex homework. Okay, so the first problem, simplify the square root of 27 times w to the 14th. Assume that the variable w represents a positive real number. And when it tells us that it represents a positive real number, it's just saying, let's not worry about absolute value for this problem. Okay. So our final answer is not going to have absolute value. Okay, so 27 times w to the 14th. And when we have radicals like this that are a product, we can break it down into separate terms. So we have 27 times the square root of w to the 14th. Okay, we can break the square root of 27 down further into the square root of 9 times the square root of 3. And the square root of 9 is 3, so we're going to be left with 3 times the square root of 3. And the square root of w to the 14th, the answer is w to the 7th, and if you're not sure why, this is why. So w to the 14th. And what a square root is really doing is you're raising it to the 1/2 power. Okay, so we're going to have w to the 14th to the 1/2 power. And exponent rules say that when you have exponents stacked like this, you multiply them. So we're going to be left with w to the 7th, because 14 times 1/2 is 7. Okay, so we're going to have 3 times the square root of 3 times w to the 7th. So our final answer is 3 times w to the 7th times the square root of 3. And really, this is just a rearrangement of what we wrote here. These two are actually just equivalent. But usually by convention, we leave the square root at the end. Okay. So the square root of x to the 13, simplify. Okay. So x to the 13, and that square root is 1/2, as we mentioned earlier. So we're going to have x to the 6.5. And that's going to be equal to x to the 6th times x to the 0.5. Okay, x to the 6th. And since x to the 0.5 is just the square root of x, write that. So our final answer is going to be x to the 6th times the square root of x. Okay, next one. Write the following in simplified radical form. Okay, so for the other problem, like with the square root of 27, we broke it down into perfect squares. For this problem, since our index is this number here, index is 4, we're going to have to write powers of 4. Okay, 1 to the 4 is 1, that's not very helpful. 2 to the 4 is 16. 3 to the 4 is 81. Okay, so with 3 to the 4, we quickly overshoot so we can scratch out this possibility. And we're left with two cases. 1 to the 4, we know 1 divides this, obviously. So does 16 divide 48? The answer is yes. So we can break this down to a product of 16 and 3. Okay, so we have the 4th root of 16 times the 4th root of 3. Because 16 times 3 is 48. Okay, so the 4th root of 16 is going to be 2, because 2 to the 4 is 16, times the 4th root of 3. So 2, 4th root of 3 is our final answer. Okay, for the next one, simplify. Assume that the variable represents a positive real number. Again, that just means we don't have to worry about absolute value. Okay, so let's multiply straight across. We're going to have 160 times w to the 5th. Let's break this down into the 5th root of 160 times the 5th root of w to the 5th. Okay, so w to the 5th to the 5th root, that's going to be w to the 5th to the 1/5 power. That's just going to be w. And for the 5th root of 160, let's do the same thing as the last problem. Let's try to break that down. So let's write our 5th powers. 2 to the 5th is 32. 3 to the 5th is equal to 243. Okay, well, obviously, since this is 160 and this is 243, 3 to the 5th overshoots, so that cannot be a possibility. So now we're left with the question, does 32 divide 160? And the answer is yes. So that means we can break down 160 into the fifth root of 32 times the fifth root of 5, because 5 times 32 is 160. So we're going to have 2 times the fifth root of 5 times w, and this is equal to 2w times the fifth root of 5. And again, we leave the radical at the end for convention. Okay, multiply. Simplify your answer as much as possible. Okay, let's distribute the square root of 5. So 4 times the square root of 6 times the square root of 5 is going to be 4 times the square root of 30. And the square root of 5 times the square root of 5 is just 5. So we have minus 5. And do we have any perfect squares that divide 30? Okay, 1, 4, 9, 16, 25. Nope. So this is our final answer. 4 times the square root of 30 is simplified as much as possible already. Okay, next one. Multiply. Simplify your answer as much as possible. Okay, let's use FOIL, since this is a binomial times a binomial. Okay, so we're going to take the product of the first terms, the outer terms, the inner terms, and the last terms. Okay, first terms is 2 times the square root of 10 times 2 times the square root of 10. So 2 root 10 times 2 root 10. We're going to multiply the 2's and multiply the square root of 10's. So 2 times 2 is 4, and the square root of 10 times the square root of 10 is just 10. So we're going to have 40 for our first term. Okay, now for the outer terms, which is going to be 2 times the square root of 10 times negative 6 to the times the square root of 3. So 2 times the square root of 10 times negative 6 times the square root of 3. Okay, same thing. We're going to multiply this number by this number, and then the radical by the radical. So 2 times negative 6 is negative 12, and the square root of 10 times the square root of 3 is the square root of 30. Okay, final answer, negative 12, square root of 30 for the outer terms. And now for the inner terms, we have 5 times the square root of 3 times 2 times the square root of 10. Okay, 5 root 3 times 2 root 10. Okay, 5 times 2 is 10, and the square root of 3 times the square root of 10 is the square root of 30. Okay, let's write this upside here again. 10 times the square root of 30. And now for the outer terms. Sorry, the last terms. Okay, that's going to be 5 times the square root of 3 times negative 6 times the square root of 3. 5 root 3 times negative 6 root 3. Okay, 5 times negative 6, that's negative 30. And the square root of 3 times the square root of 3 is going to be 3. Okay, we're going to have negative 90. And now all these terms we've collected, we're going to add them. Okay, so 40 minus 90, negative 50. And 10 root 30 minus 12 root 30 is going to be minus 2 root 30. And that's our final answer. And here we could have also used an aerial model, but foiling is just one method to do it. Okay, multiply and simplify. The square root of x minus 3 times the square root of 2 times the square root of x plus 3 times the square root of 2. Okay, so let's call the square root of x a, and 3 times the square root of 2 b, and rewrite this equation. Let's see what happens. So we're going to have a minus b times a plus b. That's the difference of squares. That's equal to a squared minus b squared. Let's do that. So the square root of x squared is x, and 3 root 2 squared. Let's find that real quick. 3 root 2 times 3 root 2. 3 times 3 is 9, and the square root of 2 times the square root of 2 is 4. So 4 times 9 is 36. We have x minus 36. Okay, for the next one. The square root of x plus the square root of 2 squared. Okay. So let's do the same thing. This is a and this is b. So we have a plus b squared, and that's a squared plus 2ab plus b squared. And if you can't remember that, we can just derive it really fast. So a plus b times a plus b, a squared for the first terms, plus outer plus ab for the inner terms, plus ab for last terms, plus b squared. And that's a squared plus 2ab plus b squared. Okay, so now we're just going to substitute. So a squared, that's going to be square root of x squared. So that's just x 2ab. So ab is going to be square root of x times the square root of 2, which is going to be the square root of 2x. And that times 2 is going to be 2 times the square root of 2x. And for b squared, that's going to be the square root of 2 squared. And that's going to be just 2. And here, if you just did the square root of x squared plus the square root of 2 squared, that's incorrect. So this is not equal to square root of x squared plus the square root of 2 squared. These are not equal. This is a common mistake. The reason this is incorrect is because when we write this out as the square root of x plus the square root of 2 times the square root of x plus the square root of 2, we're not multiplying each term by each other term. It does not follow FOIL, in other words. So this is an incorrect answer. This is the correct answer. Okay. Rationalize the denominator and simplify. Okay. So we're going to have 4 divided by the square root of 7. And what it means by rationalize, it just means get the radical out of the denominator. And we can do that by multiplying by the square root of 7 divided by the square root of 7. And since the square root of 7 divided by the square root of 7 is actually just 1, we're not changing the value of the first term in any way. We're just manipulating it. Okay. Multiply straight across. So 4 times the square root of 7 divided by the square root of 7 times the square root of 7. That's just 7. Okay. And since there is no longer a radical in the denominator, we have rationalized it, and we are done. Okay, next one. Rationalize the denominator and simplify. The square root of 638. Okay, so let's simplify that real quick. 6 divided by 30 is just 1/5. So the square root of 1/5. And with radicals, and when we have division, we can distribute the radical. So we can write that as the square root of 1 divided by the square root of 5. This applies for higher powers, by the way, as well. Okay. The square root of 1 is just 1. So 1 divided by the square root of 5. And remember, it says to rationalize. So let's do the same thing as last time. Times the square root of 5 divided by the square root of 5. It's going to be the square root of 5 divided by 5. And since there is no longer a radical in the denominator, we're done. Rationalize the denominator and simplify. Here, since we have a plus sign here, and no like terms, we have to use something called the conjugate. First, let's write this out. Here, we cannot multiply by 3 times the square root of 5 plus 6 divided by 3 times the square root of 5 plus 6, like the other problems, because that would actually just make it more complicated. So what we have to do is multiply by the conjugate, which is just the denominator, but you switch the sign in the middle. So 3 times the square root of 5 minus 6, that's the conjugate, divided by 3 root 5 minus 6. And again, since we have the same thing on the top and the bottom, we're not actually changing the value of the first term. Okay, so let's just find that real quick. So distributing the 2 to this and to that, we're going to have 6 root 5 minus 12 divided by, and here again, this is a difference of squares because this is a plus b times a minus b. That's going to be a squared minus b squared. And a here is 3 root 5 and b is 6. So 3 root 5 times 3 root 5. That's going to be 9 times the square root of 5 times the square root of 5, which is just 5. So 45. So a squared is 45, and b squared is just 6 squared. So minus 36. 6 root 5 minus 12 divided by 45 minus 36, which is 9. Okay, and since we can bring out a 3, we can divide both sides by 3. We can do that. So 6 divided by 9, 2 thirds root 5, negative 12 divided by 3 is 4. And this is the final simplification. We divided the top and the bottom by 3. Okay. Simplify. The square root of 28 plus 2 times the square root of 63. Okay, the square root of 28, we can write that as the square root of 4 times the square root of 7 plus 2. So fast forward, 2 times the square root of 63 would be the square root of 9 times the square root of 7. Okay, the square root of 4 is 2. So 2 root 7 plus 2 times the square root of 9. That's going to be 2 times 3, which is 6. 6 root 7. And here we have a like term, which is the square root of 7, or sorry, common factor. So we can do 8 times the square root of 7. If you understand why we can do that, we can think of the square root of 7 as an x, and we would have 2x plus 6x, and we would have 8x. And plugging x back in, we would have the square root of 7, which is 8 root 7. Okay, simplify. 5 times the square root of 48 plus 6 times the square root of 3 minus the square root of 27. Let's use the same thing. 5 root 16 times the square root of 3 plus 6 root 3 minus this, the square root of 9 times the square root of 3. Okay, so the square root of 16 is 4, so this turns into 20 root 3 plus 6 root 3 minus the square root of 9 is 3, so that would just be 3 root 3. And here we can think of the square root of 3 as an x. So it's 20x plus 6x minus 3x. That would be 20 plus 6 minus 3. So that would be 23 times the square root of 3.